Hello everyone, welcome back to Piece of Physics. In the last video of vector calculus, we just completed our scalar product or dot product. In this particular video, we are going to see vector or cross product. In this particular product or multiplication of vectors, our resultant is basically vector. Okay, so here we will multiply two vectors and its resultant will be also vector. Okay, so such kind of multiplication of vectors is known as vector product or cross product. Okay, now let us look into this particular vector product thing. Okay, like this. In the plane we have two vectors. One is here, another vector is somewhere here. Now this particular vector is your vector A, this particular vector is your vector. Both the vectors have angle in between them is theta. Okay, now both the vectors are in a same plane but are at some angle theta. Okay, so the resultant of this particular vector, okay, now the product of two vectors is taken as A cross B. Okay, so basically this sign represents cross product. Okay, its resultant will be A magnitude B magnitude into sine theta, where theta is the angle between both the vectors A and B, into there will be a vector n cap. Okay, basically n cap is your unit vector. Okay, the direction of this particular unit vector is determined by the right hand screw rule, right? So what we will do is, okay, we have to put a screw like here. Okay, now we have to take cross product of A and B. Okay, so basically it is A cross B, so we will rotate our screw from A to B. Okay, so our screw will be rotated in this particular direction. Okay, direction of this screw will be always from A to B if there is A cross B. If it is B cross A, then we will rotate the screw from B to A. Okay, now by rotating this screw will move in this particular upward direction. Okay, so the direction of this particular rotation of the screw, okay, will give us the unit vector n cap. Okay, so always remember this direction of n cap will be always perpendicular to B and A separately. Also you can say that the direction of n cap is also perpendicular to the plane containing vector A and B also. Okay, now if we take B cross A, okay, in the case of B cross A, our screw will be rotated in this particular direction, so basically it will give you the A cross B, but direction of this particular n cap will be inverted, so there is a sign of negative. Okay, so here you can see that the magnitude of A cross B will be only A sine theta. Okay, the magnitude of n cap is our unit vector, so the magnitude of n cap will be always 1. Okay, now we have A cross B equals to AB sine theta. Okay, in case of theta equals to 0 or 180 degree, okay, sine 0 or sine 180 both are 0. So in this case our A cross B will be 0. If theta equals to 90 degree, in this case sine 90 is 1, our A cross B will be equals to only AB and the magnitude of A cross B will be just A into B. So this is the maximum value of A cross B which occurs in the case of theta equals to 90 degree. Theta equals to 270 degree, so sine 270 is -1. This is A cross B equals to, okay, so in this case the answer will be minus AB n cap. So this is the minimum value of A cross B. Okay, so minimum value of A cross B occurs in the case of angle of 270 degree, which is basically 3 pi by 2 radian. This is pi by 2 radian. This is 0 or pi radian. Okay. Now let us consider few examples or quantities in which our cross product is being applied. Okay, so first of all, our torque. In case of torque, we have tau equals to R cross F. Our torque is cross product of position vector and the force. Our second quantity is angular momentum. In case of angular momentum, we have L equals to R P. Now let us consider different angles. In case of theta equals to 0 degree or 180 degree. Okay, so here we can say that in case of let us first consider the angle theta equals to 0 degree. Okay, in this case we have A cross A equals to 0 because the both the vectors are parallel and theta will be 0. Is I cross I, this is also 0. J cross J, this is also 0. K cross K, this is also 0 because these unit vectors are parallel to each other. Okay, that's why the cross product of both the vectors will be always 0. Our second type of angle is theta equals to 180 degree. Okay, in this case I can take A cross minus A. Okay, here you can see that in case of A cross minus A, our angle of sine 180 is also 0. So also A cross minus A will be your 0. Okay, if theta is 90 degree. Okay, this angle is 1, right? So her so in this case we have I cross J. Okay, so magnitude of I into magnitude of J into sine 90. Okay, now if I rotate I to J, okay, so you can see that this is I direction, means x axis, this is y direction, this is J cap, and in this particular direction we will have in the plane this direction we will have K cap. Okay, if I rotate the screw from I to J, our screw will move inwards, so basically the resultant of this particular I cross J will be in the K cap direction. So here we will get K cap. So here you can see that I cross J, the magnitude of I is 1, magnitude of J is 1, sine 90 is also 1, so the magnitude of I cross J, so the resultant of I cross J will be always K cap. Secondly, we have J cross K. Okay, so J cross K will be your I cap, and K cross I will be J cap. Okay, so here you can say that I is J and this is K. So I can take it clockwise. I cross J is K, J cross K is I, and K cross I is J cap. Okay. Now J cross I is minus K cap. K cross J is minus I cap, and I cross K is minus J cap. Okay. So in this case, you can see that our direction of this particular rotation will be in the anti-clockwise. Okay, so in the anti-clockwise direction our resultant will be always negative, right? Our another property is distributive property. So we have distributive property. So in this case we have A cross, in the bracket we have B plus C. Okay, so the resultant will be always A cross B plus A cross C. Okay, so we have addition of two vectors b and c, and we take cross product of this addition with another vector, so you can distribute the cross product like this. Okay, so in the algebraic method how we will deal with the cross product. So consider two vectors a. We have vector a as ax I cap plus ay j cap plus z k cap. B equals to, we have b I cap plus by j cap plus bz k cap. Okay, so what we are going to do is we are going to take it as a cross b. Okay, so let us make one determinant like this. This is I cap, this is j cap, this is k cap, this is ax, ay, az, this is bx, by, bz. Okay, so basically the resultant. Okay, now we are going to find the resultant of this particular vector. Okay, also you can to solve this particular problem, okay, what we are going to do is, if we have a cross b, so in the first row we are going to always put a vectors component. Okay, and secondly we have b, so we are going to put here b vectors components. Okay, so what will be a cross b? Okay, so to find the a cross b, we know that we have only two vectors, j cross k is I cap and k cross j is minus I cap. Okay, so in case of j cross k, what we are going to do is ay bz. So ay bz in this particular direction. Okay, ay bz. So ay bz is j cross k. So this will be plus I cap. Now az by. Okay, k cross j. Okay, so we will get plus az by. But our k cross j is minus I cap. So this will be minus I cap plus. Okay, now let us remove this particular. Okay, now to find the j cap. Now to find the j cap component of the cross product, okay, so what we are going to do is, we know that I cross k is minus j and k cross I j cap. Okay, so here we are going to take it. Okay, so k cross I, so we will get azbx. This is azbx. Okay, azbx will be k cross I, so it will be j plus axbz. Okay, so I cross k, we know that I cross k is minus j cap. Okay, so a plus axbz minus j cap plus. Okay, now we are going to find the final k cap product. Okay, so what is k cap? K cap is generally the cross product of I cross j, it is k, and j cross k will be minus k. Okay, so I cross j is our ax by. So this is ax by. Ax by is k cap plus ax is minus k cap. Okay, so what we are going to do is, this is ay bz. Okay, so what we are going to do is, we will going to, so what we are going to do is, we will keep I cap in. What we are going to do is, we just add the components of I cap I cap. Okay, so what we'll get is I cap will be outside the bracket. Here we will get ay bz minus az by plus cap is az bx minus x bz plus k cap is ax by minus ay bx. Okay, so the resultant of a cross b will be particularly this much. Okay, so this was all about how to deal with this cross product in the algebraic manner.